First of all, Storm for real-time analytics. What is Storm? Use cases of Storm, components of Storm, properties of Storm, and Storm versus Hadoop. And across the module 2, we would actually go basically on Storm technology stack and grouping, where we'll actually go into the Storm installation, Storm running modes, creating first Storm topologies in basic topologies in Storm. So we would actually be covering most of that, and today we would not be actually covering. We would be actually covering on a pseudo run mode, and furthermore we'll actually see how we'll have to actually try a couple of topologies today. Okay.
Okay.
So so basically, let me actually ask you a question, Mubarak over here. What's your experience of big data, and what's your understanding about big data?
Well, I've been working on. I'm a big data architect working for a startup here. So yeah, I've worked on a couple of POCs here, and one of the production systems, developing applications on Hadoop, using a little bit of Scoop, Flume.
Okay.
So I have experience with Scoop, Flume, but I'm more interested to know more on Kafka and Storm. And I definitely have experience with NoSQL database like Cassandra, and using the business intelligence to BI tools like Tableau.
Okay. And
so I want to basically see how I could, effectively use to gather data using Storm and Kafka. Basically interested in the Storm and Kafka integration.
Okay. Okay. So good. So what are the, so yeah, I mean basically like on a normal for making our understanding very clear, let's actually start with the properties of big data. So why do we actually call a data set big data?
The data set is way too large.
Okay. So I would actually put it this way: a data set enough Okay. And why do we want to actually interpret this information?
To gather information, to gather intelligence out of it. So
yeah, that's a very important thing. That's the reason I'm asking you that. Why do we want to interpret information? You said to gather intelligence?
yeah.
Okay. Now, if we were to actually talk a smaller data set, would you call it intelligence?
Yes, I would definitely, we could call it intelligence, because sometimes it's not easy to, like if you're doing a POC or thing, you definitely work with little bit of a smaller data set, a sampling data set, to know, at least we get some understanding of intelligence, some understanding of the data, some understanding of, some information of the data.
Okay. So why I actually
If
brought
not
this
more.
point out, yes, why I actually brought this point out is it's very important to actually understand when there's so much of hype of big data, and you know, people are all behind big data. So
Right.
what is it that, you know, this big data is giving us different from the small data sets that we used to actually do analytics on? So you know, the answer to this is mostly no.
Mostly no. Okay.
Yeah, because when we actually take information from a data set, it is mostly some numbers. It is not intelligence. It is some kind of summary or information that is actually used for some metrics or kind of analysis. Okay. So again, going back to, you know, I'm just making the basis very clear so that, you know, it makes sense of, you know, what we are actually trying to do. Okay. So how do human brains work in the context of data gathering, data analytics, and data correlation? How is it different from a small data sets? Do humans actually work on small data sets or big data sets?
Small data sets.
Yeah, that is from a, you know, from a database architect point of view. I'm talking from a human brain perspective. Like for example, you are actually planning for a trip, or you are actually you know, deciding on buying something. How do your brain actually try to process? It actually tries to gather as much of information as possible.
Right.
Yeah, as much of data and as much of information. Very important, data and information, right? So the base idea is that, like, when you actually have a larger data set, you predominantly talk about something called the Bayesian law,
Bayesian law.
right?
Yeah.
So this is mostly how human intelligence is generated. Okay, so we take a bigger, larger data set, and then we actually try to actually find a particular pattern or an information from that particular data set, and then make a judgment.
Yeah.
Right? This is a very important learning that we have to be having before we start of start of running behind big data. Why? Because when we actually talk about smaller data sets, we are talking about we need to be actually some amount of statisticians, some amount of database architect, some amount of technical architect, some amount of Java, some amount of all languages. I mean, all these mix is pretty much required if we are actually providing a right solution, right? Okay. So why a small data set is actually different?
What is the rhythm?
Okay, so this is one of the questions that we could ask, right? Because the problem is, if we actually say this small data sets actually shows me a particular pattern, and say that let's say like all animals have 4 legs, something like that. So the point is, it always depends on the universe that we are actually talking about. Okay. So if you take the life of computer science also, so we started off actually getting computers into the world because we wanted to solve bigger data set problems using mathematics, right? And at one point we understood that we cannot scale. We could not scale. So we stopped it over there, and all the different business suites and applications were actually byproducts of the languages that was actually created for this mathematical discovery or mathematical evolution that we were actually talking about. But what happened towards or recently is that the theoretical distributed computing, right?
Right.
That's what everybody is behind Hadoop for, right? So what happened? Everybody is behind Hadoop to actually solve one problem or the other, right?
Right.
Let's take another sheet. So let's now talk about distributed computing. And so next, now we have actually come into more technology. Hadoop, computing. Okay, so you said you are from the BI world, right? Or you have some experience, or you have predominant experience on the BI space. So we would basically talk about data warehousing.
Okay.
Or enterprise data warehouses, right? So for enterprise data warehouses, we would actually look into maybe an in-house solution or something like Teradata.
Teradata, okay.
Okay, and there are enormous, like you can actually talk about enormous tools used on this, and let's actually talk about something that starts helping us to query on this Teradata, or helping us to query on this big data space, or the so-called big data of the last decade, like business objects, right? We would start using some tools like this.
Right.
Now the problem all these tools are actually facing in the facing today, right? What are the problems that these tools are facing today? Or let's put it in a different way. What are these tools not providing us? Or making our life miserable.
Miserable.
Could you actually come up with something?
I've not worked with those, so I don't have much idea what it provides and what it don't provide. I just went with the tool which the world uses, and just moved ahead with it.
Okay, no worries, Mubarak. So why I'm actually asking you this question is, being an architect, or being a big data architect.
Right.
These are a couple of thoughts that would actually help us.
Right.
So what are the couple of problems that we are actually facing in these tools? One is licensing.
Okay. But even Tableau has a licensing thing.
Yes, it has a licensing thing. I'll come to that.
Yeah.
Licensing. Okay. Another thing is scalability.
Right.
Computation potential, right? So these are a couple of now this does not actually really talk about what we are trying to say over here.
Right.
Okay, what we are trying to say is, again, going back to our brain story. How do these systems grow? Okay, and next question is, how do our brain grow? So our brain is also something like a computer, right?
Right.
Yeah. So what is the difference? Like our brain is still be able to actually grasp more information, more knowledge, and do more analytics. But our systems are actually giving us nightmares now. Why? Or why do you think? Right? And how does our brain grow?
Scale. Horizontal. Has the possibility of vertical scaling. Okay, that's a system.
Exactly. Okay. So what do you mean by horizontal scaling now? Our neurons do not actually improve their computation power, right?
Right.
It's very simple. It's very simple. It just does what it does, right? But what are, you know, our architecture, our big data architect, not big data, our BI space architecture until today been trying to do? Trying to actually grow something on a vertical scale.
Vertical scale, yeah.
Okay, so it talks about no, okay, that's what happens after a long time. It goes down. Anyway, we're talking about vertical scaling and horizontal scaling.
Right.
This is very, very important.
Right.
The problem with vertical scaling is that, you know, you have a small box, you go in for a bigger box, you try to go in for a bigger box. This is what vertical scaling is.
Right.
Okay. What about horizontal scaling? We talk about a box, we talk about the same box, we talk about the same box, we talk about the same box, but all working together in a synergy. Right?
Right.
This is very, very important understanding about how our tomorrow's solutions are actually architected. Now let's actually correlate it back to Hadoop. So what kind of scaling does Hadoop have?
Vertical?
No, it's a horizontal scaling.
Oh yeah, horizontal.
Scaling is absolutely horizontal. But yes, there is an attribute of, you know, vertical scale part, which actually limits us to maybe 4,000 nodes to 6,000 nodes in a cluster. Yes, it does. There is a single point of failure, and, you know, then that is where we have high availability actually brought in, or, you know, the name node and a lot of things. Okay,
Yeah.
that's again, you know, back to our computers. But at least we have a scope of, you know, scaling. Right?
Right.
And this is where the first Google, the people who actually thought about this long time before, had the big table
Yeah.
and big data, right? Okay. So pretty, you know, this is pretty like story like, but this is very important to know. This is what actually leads us to what we want to learn.
Yeah. One more thing, can you go over this again a little bit, Shri? It's very important for us to know. You talked about the horizontal scaling. So the horizontal, you meant to say that the size of the boxes remains the same, but the size of the box grows, right?
No, the size of the cluster grows. Okay, let me just put it this way.
The size of the cluster grows.
Like our brain.
Like our brain, okay.
Now let's actually talk about things that we know. Okay, so the cluster grows by adding more nodes.
Nodes, yeah.
Okay, so what is the case over here? Here it is
Horizontal.
the machine is bigger machine.
Okay.
So it is like when I say bigger memory, more powerful CPU, etc., etc. Right?
So the cluster grows by adding more nodes. That is horizontal scaling. Then what we call it vertical is by adding more memory, more CPU and all that, right?
Absolutely.
To that. Okay.
So let me just, you know, make make sure I am actually putting it here so that it just gets registered into. So
Yeah.
okay, again there is a new artificial intelligence that is actually working on, which is actually predominantly working on. Yeah, we'll talk about maybe video analytics and proximity analytics. That's a new feature that is actually working on. Okay.
Right.
So video analytics is all about it's trying to actually mimic how similarly our brain actually works. Like you actually take a particular picture and start sensing knowledge about that picture.
Okay.
Okay. So that's how actually our brain actually works. Brain works on pictures. So similarly, if I actually put something over here on this piece of paper or the virtual paper, it stays in your brain. That's the reason I'm actually scattering it out and then putting it in a place so that it never loses. Okay.
Okay.
This is all about vertical scaling. And this is about horizontal scaling. Okay. Now, so then that is where Google had actually thought about this some long time before, and then had published the papers because their basic architecture belonged to that. So basically, they wanted to actually do something with the most cost-effective model and also in a scalable model. That is the reason they are still able to cope up with what they are actually doing. They try to, so whenever we try to mimic any system, for example, like object-oriented, I don't know what programming background do you come from? Do you come from a Java programming background?
Yeah,
do you come from
Java.
Oh, you are Java. Okay. So you know what object-oriented programming is, right?
Right.
Okay. So why did we actually move from a procedure-oriented programming to object-oriented programming? Because it's more natural.
Natural, yeah.
Okay.
Yeah.
So that is, so whenever it is more more aligned to the nature, it tends to actually stay, and it stays longer, and it grows keeps on growing. It's a very sustainable model.
Right.
Okay. So similarly, horizontal scaling is a very sustainable model. That's how our systems actually work. Okay.